This video will discuss Chapter 6.3, Elimination using addition and subtraction. So similar to the problems before where we use substitution, we're going to use this method when there's not necessarily an obvious way to substitute. So for example, trying to isolate either the x or the y in this particular problem is going to create a bit of a difficult situation as I try to move things to one or the other side, and then I'm going to have to do some dividing. Then when I substitute it back in, I'm going to have to do some multiplying. So there's going to be an easier way for me to solve this. And again, the idea is that I'm trying to figure out when this point and this point intersect. So when do they share a line? When are they equal? When are they the same? And so the idea is that if they are the same, I could add or subtract them depending on what it is I'm trying to do. And I want to get rid of either the x or the y. So I don't necessarily care if it's the x or the y. And so if you want to think of this as columns going down, if I were to add these two equations, which means I'm going to basically do 3 columns of addition, when I add this middle column, 6y plus negative 6y is going to give me 0. And 0y means that the y will disappear. Right? The y will be eliminated, meaning that I will only have x left. So 4x plus 3x is 7x. This gets eliminated. 32 plus 3 is 35. Now again, we're going to practice one where you're going to have to substitute, but the reason why I'm adding, I'm allowed to choose whether or not I'm going to add or subtract. The reason I'm adding is because I want to get rid of the y. Had I subtracted, I would still have an x, I would then have 12y, and I'd have 29 on this side, which means I didn't get rid of x or y. This way I got rid of the y. Now, 7x equals 35, so now I'm at a fairly simple algebra problem where I'm going to divide both sides by 7, and I got x equals 5. Again, remember, this is half of my answer. My answer, again, is written as a point on a graph, so I know that 5 is the x value. I still don't know necessarily what my y value is going to be. So to figure that out, I need to take x, and I got to substitute it back in to one of the equations above. Okay, don't spend a lot of time thinking about which equation it is you're going to substitute. Just pick one. I'm going to pick this one because it'll keep everything positive. So I'm going to go 4 times 5 plus 6y equals 32. 4 times 5 is 20. Plus 6y equals 32. Here, let's change colors. I'm going to subtract 20 from both sides. That's not a color to switch to. I'm going to subtract 20 from both sides. And I've got 6y equals 12. And then I can divide both sides by 6. And I end up with y equals 2. So then I can put the 2 here. Now to check my answer, I can put a 5 in here and a 2 in here and make sure that statement is true. And then I can also put a 5 in here and a 2 in here and make sure that statement is true. 20 plus 12 is 32. 15 minus 12 is 3. Since 5 and 2 work for both equations, this is my answer. All right, let's practice one now where I want to use a different method. So one quick thing before I switch. One thing to notice is that when these two are opposite, right? This is an addition sign, this is a subtraction sign, I add it. I want to show you one now where they are going to be the same. Right, so now I have 5x plus 2y equals 6, 9x plus 2y equals 22. These two are the same. Now coming back to this for just a second, I'm sorry, keep jumping back and forth on you. It's not so much that these signs are opposite, it's that this number and this number are opposite. So when those two are opposite, that's why I'm going to add. Over here, well, these two are both positive, they are not the same number, right? Anyone will tell you that 5 and 9 are not the same. However, 2y and 2y are the same. And since they are the same, I know that if I subtract the same number from itself, it equals 0. 9 minus 9 equals 0. 1,000 minus 1,000 equals 0. So 2y minus 2y must also equal 0. I'm going to subtract. Now, when I subtract, remember I have to subtract all 3 columns. This column is going to disappear. 5 minus 9 is negative 4x. Again, that went away. 6 minus 22 is negative 16. All right, so now I've eliminated the y, right? And as the title of this chapter tells you, the goal is to eliminate. So I've gotten rid of the y, which means I'm now just solving for x. I'm going to divide both sides by negative 4. And I know that x equals positive 4. So in my answer, 4 is going to be the x value. All right, now taking that 4, I can substitute that 4 into either of these two equations. I'll take this top one since it's smaller numbers. So this is going to be 5 times 4 plus 2y equals 6. 20 plus 2y equals 6. Subtract 20 from both sides. 2y equals negative 14. And then I'm going to divide by 2. And y equals negative 7. There's my y value. Now again, I can take these numbers, substitute them in here, and make sure my answer is true. So 4 goes here, and negative 7 goes here, and I have to make sure that that's true. And then 4 goes here, negative 7 goes there, and I make sure that's true. Keep in mind, I'm not using this sign. This was part of my problem. The blue are the original equations. So this, putting x and y in here, this would be 20, and this would be negative 14. 20 plus negative 14 is in fact 6. And down here I got 36 plus negative 14. 36 plus negative 14 is 22. Since both of these equations are true with these values, then this must be my answer. Yeah? Still doesn't work, huh? 4, negative 7. All right, so to quickly make sure we're together on this one, this, because these two numbers are opposite, I added, and because these two numbers were the same, I subtracted. So the next problem I want to take a look at is one like this. So in this particular problem, these two are the same, and these two are opposite. And so the confusion that a lot of students have with this is which one should you do? And the answer is it doesn't matter. So we're actually going to end up looking at this problem both ways. So if I were going to solve this problem thinking that these two are opposite, and since these two, I'm looking at the y's, this is a 1y and a negative 1y, they're opposite, I'm going to add. And so if I add, remember adding down, this x plus x is 2x, this cancels out, and this is 10. When I divide by 2, I got x equals 5. So the first value of my answer is going to be a 5. Now we've got to figure out what y is. So I'm going to take that 5, I'm going to substitute it in for x. It could go up into either one of the two equations. Let's just take the top one. This is going to be 5 plus y equals 6. Pretending for a second I didn't know what number I should substitute in there. I would subtract 5 from both sides. And I'm left with y equals 1. So this is 1. My answer here is 5 comma 1. 5 plus 1 is 6. 5 minus 1 is 4. Since both equations are satisfied, both equations are true, my answer is 5, 1. Now this is when I was looking at these two and I decided since they were opposite I would add. Let's take a look at the same exact problem. But now if I were looking at the x's and I said, okay, well these are the same, and so if they're the same I should subtract. So I'm going to subtract. X minus x is 0, that goes away. Now you need to be careful here because y minus negative y. It's y minus negative y, so it would look like this, is not 0, right? That in fact is actually 2y. 6 plus 4, I'm sorry, what am I doing? I'm subtracting, right? I got it confused myself. 6 minus 4 is 2. All right, now I need to divide 2 to both sides, and y equals 1. So I now know half of my answer. Again, we already kind of know what the answer should be. So I can then take that one, I can substitute back into either one of these equations. We can take the top one again just so I can show you that it's going to work. This is x plus 1 equals 6. If I didn't know what the answer was there, I could subtract 1 from both sides, and x equals 5. So what you can see is that it doesn't matter which way you solve this problem, whether it's this way or this way, both of them get us, I'll put the answers side by side, to the same place. Okay, and so this one is looking at it as the x's are the same, and this one is looking at it as the y's are opposite, but it really doesn't matter when you get a problem like this, which way you solve it. On other problems, such as this one, these two aren't the same or opposite, so you have to use the two y's, and the two y's are the same, and that's why you're subtracting there. All right, that's all we got for you on elimination using addition and subtraction. Thanks for watching the video, and I'll see you in class.